Okay, in this video, we're going to look at two new forms for our trig. So r cosine of theta plus or minus alpha, and then r sine of theta plus or minus alpha. So let's look at some rules that you need to be aware of first. So we're going to try to take some trig expressions or equations and try to write them in this form. So if a and b are positive, and we talk about a and b, we're looking here. So notice there's an a sine x plus or minus b cosine x, or a cosine x plus or minus b sine x. Okay, so this one, notice that sine comes first, can be written in this form where I have r sine of x, this could be theta, plus or minus alpha. Notice that this plus or minus is the same as this plus or minus, so whatever sign you have here, you will also have here. Okay, but a is going to be on the sine and b is going to be on the cosine. It needs to be in this order if you have a sine here. On the second one, you see I have cosine first. And so if we've written it in a different order, so if cosine is first, a is still my leading coefficient of that. A is the number in front, and then b is the number in front of sine. But this one would be written in the form r cosine of x. And then notice that this is opposite. So this is minus plus, and this is plus minus. So whatever sign you have here, you will have the opposite sign here for the cosine, okay? And again, if you're asked to write it in the form r cosine, then you need cosine to be first. So you might have to reorder your equation. Once that's true, once you've set that up, then you need to know that r, to find r, we have the square root of a squared plus b squared. So the square root of this number squared plus this number squared. And then we need to be able to find alpha, and you have two options for that. I always just pick this one and use it, but you can use either. They both work, but you really only need one all the time. So cosine of alpha is going to be equal to a, which is our first number, over r, and sine alpha is going to be equal to b over r. And this cosine alpha works for either of these two forms, just as this sine alpha works for either of these two forms. So you'll see me primarily use this one. And then alpha needs to be between 0 and 1/2 pi, unless we are in degree mode, and then it would need to be between 0 and 90 degrees. Okay, so let's look at some examples. Express y equals 3 sine x plus 2 cosine x in the form, and notice they've given it to you, r sine of x plus alpha. So they told you sine here, which matches. Most of the time it does, but you got to check that. So sine is here, comes first, and then I'm asked for sine. And so, of course, this is plus, this will also be plus. My signs match. So what we're going to do is we're going to find r first, and r is going to be the square root of whatever this number is, so 3 squared plus 2 squared, and that's this number. And you're just going to do that math. And so, of course, you get square root of 13, and we're going to leave it as square root of 13 because we don't want to write the decimal, okay? And then I need to figure out what this alpha is to be able to write it in this form. I've already found r. I need to figure out what is alpha. So I'm going to use that first formula. Cosine of alpha is equal to, and that's going to be a. So it's going to be whatever your first number was, as long as you had this written in the matching form. So whatever a is over what you found r to be, which is the square root of 13. And then you guys know how to solve this. We would do alpha equals cosine inverse of 3 over the square root of 13, making sure that we're in the right mode. And this right here is telling us that we want to be in radian mode. And so when I do that in radian mode, I get that alpha is going to be equal to 0.588. And so now that we have alpha and r, we can just go ahead and write it in this form right here that they asked for. So I'm going to have square root of 13 sine, and then I'm going to have x plus alpha. And that's my answer. That's my form. That's all there is to it, okay? Okay, let's look at this example. And notice I have two here for you because I want you to see the difference, and I want you to be very careful about what you're asked for and how your expression or how your equation was written. So in this case, I have 3 sine x, 4 cosine x, where sine comes first. They do ask me here to put it in degree mode, okay? So that's telling me I need to be in degrees. And here I'm asked for r sine of x plus alpha. So the sine matches what comes first in my expression. So for this one, I'm fine to do it just like we did last time. So we're going to find r, which is going to be the square root of the 3 squared plus the 4 squared. And that becomes the square root of 25, which is 5. And then I'm going to do cosine of alpha is equal to, remember it's going to be this first number, 3, over what you found r to be. And so alpha is going to equal cosine inverse of 3/5. And so when you do that, you get 53.1 degrees. And because I have everything I need, I can now write it in the form they asked for, which was this one. So I'm going to have 5 sine of x plus 53.1 degrees. And I'm good. I'm done with that one. Okay. But I want you to look at this one over here. Notice the difference. I have cosine here, and cosine did not come first in my expression. So I need to take this expression and I need to rewrite it as 4 cosine x plus 3 sine x. And now that cosine comes first, I can write it in this form, and notice that they've already set it up for me. This is minus where this is plus, because with the cosine equation, these are opposites. So now that I've rewritten it, and you have to pay attention to that, I can do r, which obviously is going to be the same because I'm using the same numbers, but I'll have 4 squared plus 3 squared, and so I'm going to get 5 again. But in this case, I have to do cosine alpha equals, a is now 4, and that's what's going to get you if you don't pay attention to this form. You're going to use the wrong value, and then you're going to have the wrong value for alpha. So you have to have these two match. Whatever this is, this has to come first in your equation. And so I'm going to have a, which is now 4, over r, which is 5. And so again, I'm going to do alpha is equal to cosine inverse of 4/5. And so I'm going to get that alpha is equal to 36.9 degrees. And then when I write it in this form, I'm going to pay close attention to what sign I should have, which they've written for me, but I have to make sure to write that. And so I'm going to have 5 cosine of x minus 36.9 degrees. And so that's the difference between these two. They're not the same, and you have to be careful about what order they gave you the expression in, okay? Okay, I want you guys to take a minute, and I want you to pause the video and try this problem and then check your answer with me. Oh, let me mention that there is a typo on yours. This should be greater than 0. R is always going to be greater than 0. And I think on yours it says less than on your notes. Okay, so fix that. But then pause the video and give this one a try. Okay, so let's look at this one. Again, I have square root of 3 sine theta minus cosine theta. So sine comes first, and I'm asked for the form r sine. So I'm all set. Okay, so I'm going to do r equals the square root of. Now, this is going to be the square root of 3 squared plus, this has a 1 in front of it. When we don't have a number, we have a 1. So 1 squared. And then the square root of 3 is, of course, 3. So I'm going to have 3 plus 1. I'm going to end up with the square root of 4, which is 2. And then I'm just going to do cosine of alpha is equal to a, which in this case is square root of 3, over r, which is 2. And I'm going to solve for alpha, which you guys know how to do. And always check. In this case, I'm in radians. And so if you're doing this in your calculator, when you get an answer, hit that button that changes it from the decimal to the radian to see if you get a nice number. You actually get pi over 6 for this. So we're going to want to write it as pi over 6. Okay? And now I can write my 2 sine theta in this case, because they gave us theta instead of x, minus pi over 6. And that's my answer, okay? All right. So this one's just a little bit different. It says state the maximum and the minimum. And I did give you the same expression here, so the one that we just used. So we've already written this in the form we need. So from the last slide, we have written this as 2 sine of theta minus pi over 6. And that's going to make it a little bit easier for me to find the maximum minimum values than this form, okay? So if you remember, sine and cosine oscillate between -1 and 1. They'll never go higher than 1. They never go lower than -1. So this is going to be -1 to 1. So the highest value that this part of my equation takes is 1, and the lowest value it takes is -1. And then, of course, I have this 2 in front. So all I have to do is 2 times -1 is -2. And then 2 times the positive 1 is positive 2. And so, of course, this is obviously the minimum, and 2 is the maximum value that it'll take. And that's not too bad. You just got to remember that, okay? Okay, we're going to look at one more problem. So there's a couple parts to this. It says express 5 cosine x minus 12 sine x in this form. So the first thing we're going to check is cosine comes first, and I have cosine here, so that's fine. Where r is greater than 0, and that's always true. And they're telling me to use degree mode. And then it says solve this equation. So we're going to not worry about that yet. We're going to take this first equation and we're going to write it in the form we're asked for. So we're going to say r equals the square root of, and I'm going to have 5 squared plus 12 squared. And that's going to give me the square root of 169, which is going to give me 13. And then I'm going to do cosine alpha equals, remember a is this first number 5, over what I found r to be, which is 13. And so in this case, because we're in degree mode, alpha is going to be 67.4 degrees. And then I can write this in this form that we were asked for. So I have 13 cosine of x plus 67.4 degrees. So I've done part 1. Okay, I want you to look carefully at part 2. They're asking me to now solve this equation. So I want you to look at the difference between this and what we were given up here. The only difference is that they've taken this x and replaced it with 2x. So I can take this answer that I've gotten, 13 cosine, and I can replace my x with 2x because that's all they did. Everything else was the same on that left side of the equal sign. I had 5 cosine x minus 12 sine x, and now I have 5 cosine 2x minus 12 sine 2x. So I can just replace the x with 2x. And then, of course, they're asking me to set it equal to 9 and solve. And they've given me negative 180 to 180 degrees as my domain there. Okay, so we're going to see how much you remember from last year for solving when we have more in here. So I'm going to first go ahead and divide by my 13. So I'm going to have cosine of 2x plus 67.4 equals 9 over 13. Now, I'm going to choose to let this equal a different variable so that I can work with this and then go back at the end. So I'm going to say let y equal 2x plus 67.4, which then allows me to solve cosine of y equals 9 over 13, which you're more familiar with. But we need to make sure that we're going to be able to end up in the domain that's given here. So remember, when we do this, we always adjust our domain based on y. So this domain is based on x. So to get a domain based on y, I take these x values of negative 180 and 80, and I plug them in here for x. So when I take negative 180 and I multiply it by 2, and I add 67.4, I get negative 292.6. And then I'm going to have y, and then when I do the same thing to the 180, I multiply it by 2, and I add 67.4, I'm going to get 427.4. So these are degrees. So I want to get answers that are within these two values so that then I can change them, and when I change them, they'll be between negative 180 and 180. Okay, so then I'm going to do y equals, and you guys know cosine inverse of 9 over 13, and that's going to give me a y value of 46.2 degrees. And I am writing kind of small because I think I'm going to run out of room, but 46.2 degrees. Now, remember your rules for cosine. You get your 46.2 degrees, okay? You then take the negative or the opposite version of that, and both of these we can add or subtract 362. As long as we're within these two values we found here. Okay, so subtracting 360 from 46.2 puts me too far in the negative. It doesn't work. So let's add 360 to it. When I add 360, I get 406.2, and that is within these two numbers, but you can see that if I add 360 again, I'm going to be outside of that. Okay, again, subtracting 360 from negative 46.2 doesn't help, but I can add 360 to it. And when I add 360, I get 313.8. So right now I have 46.2, and I have 406.2. I have negative 46.2, and I have 313.8. And all of those are between these two numbers. And these are all y values. So the problem now, and I'm very close to the end, but the problem now is that I need to change these back to x values. So I'm going to take this equation that we wrote, and basically I'm going to plug each one of these in for y. So I'm going to say 46.2 is going to be equal to 2x plus 67.4, and I'm going to solve for x. Okay, and so when I solve for x on this one, I get negative 10.6 degrees. And I'm going to do that for each one. So I'm going to say 406.2 equals 2x plus 67.4. And then, of course, you guys know how to solve for x. And so when I do that one, I get 169.4 degrees. Okay, I'm going to do it for the negative 46.2, which is going to equal the same thing. And then I'm going to solve for x. And so I'm going to get x equals negative 56.8. And I'm going to work over here, and I'm going to do the same thing for the 313. So 313.8 is equal to 2x plus 67.4, and then solve for x, and x is going to give me 123.2 degrees. And I want you to notice that all of these are x values, and all of these values are between negative 180 and 180. So it worked out that I got all of my answers within the right values, okay? And we did that because we adjusted the domain. Okay, I will see you in class.